Dr. Jaffe, will you please explain in simple terms the development of acquired immunity through the process of exposure to antigens?
Yes, and I do have to define a few of the words, including antigen. An antigen is something big enough that your body recognizes it as foreign. Now, those antigens can be digestive remnants. Those antigens can be from things you breathe. Those antigens can be from organisms, bacteria, viruses. There are many, many kinds of antigens. When we're healthy, we have a protective surface layer in regard to our skin, in regard to our mucosa from our lips to our tush, with regard to our respiratory tree. We should have mucins that trap anything that's foreign and invite our cells to come recycle that material. We should have secretory IgA, a very specific kind of antibody, a non-specific one, that just says, are you foreign? If you're not me, you're foreign. And that's what secretory IgA is meant to do. And then there are things called defensins and opsonins that also serve these functions. Now, these are elective protective mechanisms. Your body can survive without them, but it cannot thrive without them. Without them, your body becomes hospitable to infection. And we'll get to the answer to the question, but we have to first acknowledge that you would want your mucosa to be protective of you. And then, if something got in through that or past that, it should be taken up by the innate immune cells, the 50 billion dendritic wiggly cells, the granulocytes and fibroblasts and monocytes and macrophages and eosinophils and basophils. It should be taken up by them, put in the lysosomal recycling center of the cell, and broken down to the elemental building blocks, amino acids, carbohydrates, fats, etc., minerals, cofactors, and those can be given to the cell for its metabolic retuning. Now, when the elective protective system isn't sufficient, and also the innate immune system is not able to recycle the foreign invader, then we have a reserve system called adaptive. And adaptive comes in three basic categories, according to the Jelen-Koons nomenclature from roughly 1967. And it says that you can have what we now call B-class lymphocytes. These are white blood cells called lymphocytes of the B class. And when they are presented with a foreign antigen that's been processed by an antigen processing cell, an APC antigen processing cell delivers the processed antigen to a very specific site on the lymphocyte. And that lymphocyte says, oh, I've seen you before, and that turns the lymphocyte on because it's already been programmed to see that substance as a foreign invader, as something harmful. So that's the reserve system that relies on B-class lymphocytes and antibodies. Then there's immune complexes, so-called type 3 reactions or immune complex reactions, where you have an excess of antigen that's not been filtered by the spleen and liver. The body has made antibodies that are complement fixing in order to neutralize the antigen, but that would harm your blood vessels if the complement fixing antibody got to the arteries or to the blood vessels. And so the body makes an IgM antibody to wrap around the IgG antigen complex, and that's called type 3 reactions. And then you have probably the most important, which are type 4 reactions. These are T cell reactions. T cells do not require antibody. They react directly against the foreign invader if they recognize it as foreign. And you can, with functional immunology, the LRA lymphocyte response assay, now measure the type 2, 3, and 4, the B cell antibody reactions, but you only pick up the harmful antibodies, not the helpful neutralizing antibodies, because lymphocytes react against harmful complement fixing antibodies. They don't react or turn on for neutralizing beneficial antibodies. Immune complexes are detectable in this same ex vivo lymphocyte response assay LRA cell culture. And the T cells, when they light up, when the T cells activate, we can see that as well in the same autologous ex vivo lymphocyte response assay LRA test system. Now, we've been doing it since 1983. We have the most precise cell culture. We have the first one-step amplified procedure. We have an ex vivo procedure, which means that when we measure a reaction in the laboratory, it's occurring just as it would in the body. So if you want advanced functional testing of the delayed adaptive reserves, and many people are using that now and need to rehabilitate it, restore tolerance in it, make it more functionally resilient and reserved, then you would want to do the LRA by ELISA ACT tests.